Hey guys, HackerSploit here, back again with another video, and I know it's been a while, but a lot of exciting stuff to go to get into. Now, in this video, what we're going to be doing is taking a look at how to leverage an Apache2 Rootkit during your red team op, specifically for persistence and defense evasion. Now, the screen you're currently seeing is sort of an older version of this guide that I'd worked on previously, if you remember. And the problem with that, if you remember, or if you can recall, was that you sort of had to set up your own environment to do this. Now, what I've been working on doing, as I mentioned, a while back in a couple of other videos, was, sort of revamping the way I thought of delivering this type of training, because again, in order for you to get the best or the most out of what I demonstrate or what I go through in videos, you should be able to again get into an environment that's already ready for you to go. And unfortunately, some of the other platforms just weren't cutting it in that I couldn't create the advanced environments that I required. However, as you remember, a few videos back, when I published the first pen testing diary series, which will be continuing on, I utilized the CyberRanges platform, and I was actually able to build this particular lab, the Apache2 Rootkit lab, and it's currently on the CyberRanges platform. So if you're not familiar with this platform, I'd mentioned it a few videos back in the first episode of Pen Testing Diaries. It's again a CyberRange, as the name suggests. You can access it via the URL app.cyberranges.com. Link to this will be in the description section, as well as a direct link to the lab. The lab can be played absolutely for free. It's under the community free section, so Red Team Tradecraft, you can see that right over here. So this is completely free to play, and I just added this one for now. I'll be looking to port some of pretty much all of the previously used labs or setups or configurations that you had to set up locally onto the platform. So do stay tuned for that. There's also quite a bit of other stuff, quite a bit of stuff apart from this particular series that'll be on here. But yeah, so you can just register for an account on app.cyberranges.com if you haven't already. It's free, and these particular labs are free. We also have the adversary emulation playlist of labs, which we're actually going to be going through. Really excited about that in December. And there's also some of the CVE labs. Actually, this one was already ported a while back. There's a video I had a while back on the dirty pipe vulnerability where I actually, developed, I would say, a pretty good exploit for this. You can check that video. The GitHub repo is pretty much based on this. Anyway, so the focus of this video is going to be, again, a continuation of the Red Team series, but now moving into Tradecraft and, the actual operations. So this is an update of this particular walkthrough here that I have on the HackerSploit blog, and you'll actually see the improvements made where now it's sort of contextualized or placed in a more realistic environment. So again, you can just start up the lab, just takes a few seconds to start up, and you'll be provided with access to a pre-configured Kali Linux system, pretty much everything you need. So the scenario or the scenario in question is, again, all based on what you're likely to find in the real world. That's sort of the objective for the Red Team Tradecraft series. And what we're going to be doing is, you can go through the introduction, but the objective here is, why would you need to use this particular rootkit? And as you can see, based on the title, it's mainly on defense evasion, and I'll explain why. In addition to defense evasion, you can also use this rootkit for persistence, specifically on Linux. It goes without saying. So I'll just start it up here, and we have the intro right over here. So I'm just going to go through the intro really quickly, because there's quite a bit of stuff that I've sort of included now in the update here. So this scenario serves as a guide on how to set up and maintain OPSEC during Red Team operations. In the case of this scenario, we'll be exploring how this can be achieved in instances where initial access has been obtained on a public-facing web server running Apache. Now, as you may or may not know, maintaining OPSEC during red team operations is extremely important and is something that needs to be factored into your decision making before and after initial access has been obtained. Compromising a public-facing web server does not mark the end of your activity on the target system or host. You must ensure that you've established persistence and masked your activity, which is inclusive of network traffic, the commands you're executing, etc. Masking your activity will require an understanding of how the compromised system is utilized, how it is managed, and more importantly, whether it is being monitored. For the sake of authenticity and realism, in this scenario, we will commence our operations by obtaining initial access on the target web server or to the target web server. We will then perform some local enumeration on the compromised web server, after which we'll leverage the legitimate services running on the web server or the server to establish persistence via an Apache2 Rootkit. What about, being stealthy and evading detection? Well, the Apache2 Rootkit in question is built to be stealthy and can be configured to blend activity with legitimate traffic. So with that being said, we are ready to get started. Or if you are ready to get started, you can just navigate to the wiki section where there's a walkthrough that sort of breaks down all of the phases that we'll be going through. So initial access, post-compromise, and then configuring and deploying the rootkit, and then, of course, testing the rootkit right over here. So if you're not familiar with the CyberRanger's platform, if you click on the servers tab, you can see the systems that you can interact with. You have the C2 server that's running Kali. This you can access via your browser or in your browser via RDP. So you also have SSH access, so you don't need to connect via VPN. And then we have the target web server that has the services exposed right over here. So if I just click on the RDP button right over here, you can see it's going to open up a new tab. And there we go. Just going to load it up here. Just hopefully, actually, probably need to exit full screen. Just give me a second. All right, there we go. And, the Apache rootkit has already been saved on your desktop. Don't worry, we'll get to that shortly. I'm not going to go through the walkthrough in the wiki. That is for your perusal. But we know the target IP, that's the target web server that's running on 192.168.125.100. So let's get cracking here. And I'm just going to navigate onto my desktop, and we'll start off with the basics, the standard stuff. So sudo nmap, and if I can type correctly, we're going to actually hold on, we're not going to ping, we're just going to run a synscan, and we're also going to do a service version detection scan, T4, speed it up a little bit, all ports, TCP ports, that is 125.100, and why not save the results here? So we're just going to say OX, and we're going to call this web server, and just say nmap web server and all tcp.xml. All right, so this will not really show how much time this will take. We said don't ping, it's going to do the ARP ping anyway. Actually, hold on, we probably also want to disable DNS resolution. We don't really need that taking too much of our time. There we are, much better. Actually, that's a quick tip if you want to save quite a bit of time, I should say. And I'm just going to wait for this to complete, and then we can take a look at what we have running on the target web server. And remember, the objective, as I've laid it out in the wiki section, is we're firstly going to establish or obtain initial access as clandestinely as possible, and then we're going to move on to configuring the rootkit. And hopefully this will make sense, given that this particular updated guide is built to sort of mimic what you're likely to find on a standard web server. So there we are. We can see that on the target we have SSH, we have port 80 running Apache web server. That gives us we have a banner there for the distro, and then on port 10,000 we have Webmin server running. So why don't we open up Firefox here, trusty Firefox, and let's see what we have on port 80. So 192.168.125.100. That'll open up port 80. And there we are. This, let's see what we get in this particular case. Interesting. This pretty much should give us the public-facing website. But, you know, why not? Let's check what's running on port 10,000, like so. Not 1,000, but 10,000. There we are. We have Webmin, and this is still loading. Very interesting. Probably trying to fetch some libraries and stuff. Given, yeah, this is making quite a few lookups here, but that should actually stop in a while. If I go in here, any protection? No. Anyway, that's supposed to be the public-facing website. It's not being displayed, but there is just a standard boilerplate landing page. The bottom line is we're not targeting the public-facing website. You know, it's running Apache web server, which is what we're going to use, you know, for to establish persistence. I should say stealthy persistence with the Apache2 Rootkit. Our main initial access vector is going to be Webmin. Okay, so if we take a look at the Nmap scan, we can see that it's running Webmin 1920. Okay, now I'm going to switch over really quickly into the wiki, and there's a good reason for that. So I've sort of outlined exactly what I did over here, and you can see what the landing page looks like. Now, the augmentation or the improvement that I made to the guide is to include initial access, right? So first things first, and I've sort of outlined why this is important. You can see it right over here. Before we get ahead of ourselves, we must ask ourselves the question, or ourselves the question, I should say, what exactly is Webmin? Now, this is a very important question to ask yourself. Why? The reason this is an important question to ask yourself is because it's always a good idea, a good thing to do, you know, or a good step to take before you actually move on to exploiting a particular service. So always understand what a service or application or web application does, how it works, and what technologies and or libraries it uses before you start attacking or testing it. So that begs the question, what is Webmin and what does it do, or what is it used for? Well, Webmin is a free open source web-based control panel that allows system administrators to manage Unix servers, Unix-like servers, you know, essentially configuring operating systems. Users can configure operating system internals such as users, disk, quotas, etc., modifying and controlling open source apps. So users can modify and control open source apps such as bind DNS, that is Apache, you know, PHP, MySQL. Actually starts to make sense why someone would be, or why the target organization actually set up Webmin. The bottom line is that Webmin is a useful tool for system administrators because it simplifies the process of managing a Linux or Unix system. It provides an intuitive user interface that's accessible through a web browser, allowing users to manage a server from anywhere. Now that brings us to targeting Webmin. So we know what version of Webmin we're running. So let's go back in here into the Kali Linux system, or our C2 server. Has the web app here? Yeah, there we are. It's actually loaded. Took a while, but you can see this is the target organization's website. We're not going to target this because, again, we want to be as clandestine as possible and not do anything foolish. So no file or directory brute force. Let's try and assess what we have running on the target first. So we'll, you know, just perform a quick search exploit query here for Webmin. And, you know, we can actually specify the exact version. So Webmin 1920, like so, and there we are. So in this particular case, it looks like we have two Metasploit modules. There we are. So we have the second and the third one. The first, you know, also applies, but that's a shell script. We'll get to that shortly. We then have this one right over here, which, you know, 1920 unauthenticated remote code execution. Metasploit, and RPC CGI remote code execution, all affecting the same version. This one, the final one here, affects any version prior to 1.9.20. And the best thing to do now is to sort of understand what this particular exploits are exploiting. So firstly, within the version of Webmin, 1.9.20, what exactly is causing the vulnerability, and what do these exploits do, or how do they exploit the vulnerability? Now, lucky for us, I've sort of shortened this process, and I've sort of summarized it right over here in the wiki. So the bottom line is from the preceding screenshot, searchsploit here, which we just performed, we can also extrapolate, the two of the exploits are accessible in the form of Metasploit modules, and one of the exploit is in the form of a shell script. So hold your horses. While you may be tempted to fire up Metasploit and give these modules a go to see if they work, we still do not know much about what vulnerabilities these modules exploit, as I just said. So we must perform some additional rigorous research and due diligence to learn more about the vulnerability, what causes it, and more importantly, how the exploit modules referenced above in this particular screenshot or in the searchsploit scan exploit the vulnerability. Now, as I said, I've sort of summarized the research, and I have a vulnerability analysis section here. But what becomes apparent if you perform a quick Google search is that this vulnerability actually had a CVE code or identifier assigned to it. So CVE 2019-15107. Okay, and you can see the description here. An issue was discovered in Webmin versions lower or older than 1.9.20. The parameter old in password change.cgi contains a command injection vulnerability. So let's move into the vulnerability analysis section. So now that we're armed with a CVE identifier, or code, we can narrow down our research and locate any public advisories that could potentially shed some light on what causes the vulnerability. And indeed we did. So I've actually linked a link to the advisory right over here on vulners.com. Great website, by the way, which pretty much provides us with all the key info that we need to understand in terms of, what causes the vulnerability. So this is extrapolated directly from vulners.com, hence the reference here. But we can see the name, Webmin, 1.9.20, unauthenticated. That's sort of the key thing here, which is what we want. Remote command execution. The severity is critical. By the way, all credits to the author. We can see this right over here. Vulnerable to unauthenticated remote command execution, and we can see that this is via the parameter old in passwordchange.cgi. So something to do with resetting or changing passwords. Successful exploitation of this vulnerability allows remote attackers to execute arbitrary commands with root privileges. Nice. So we get root privileges. Remediation is obviously to upgrade. And we can see the CVSS score 9.8, so pretty good or bad, depending on what side of the fence you're on. Now, as shown in the preceding analysis here or code block, this one right over here, or the whole thing, I should say, which was extrapolated from the advisory referenced earlier, we have identified the following information about the vulnerability. So the description, which I read out, and what the impact. So what this gives us, or what successful exploitation of the vulnerability provides us as an attacker, and of course the privileges required. This is something very important. So unauthenticated, which means we pretty much don't need anything, and the privileges gained, root. So this should almost be rated or ranked 10 in terms of the CVSS score. So anyway, we've got some key information. Now, based on the info we have gathered, we can deduce that successful exploitation of this vulnerability potentially allows for the execution of arbitrary commands. Yes. Okay, so before we actually run the exploit, it's always ideal to check if the web application or service is vulnerable. And that's what the shell script, listed here in the searchsploit scan does for us. So why don't we go ahead and copy it? So copy user share exploit db exploits Linux web apps, and the this is 47293.sh. I'll just copy it to the desktop here, and let's open it up here with Vim. Let's see what it does. So we can see that this script essentially checks if a target Webmin server is indeed vulnerable. So the script sends a flag by an echo command, then greps it. If there's a match, the target is vulnerable. So in essence, what this script does, it makes a request to the password change CGI script, if you will, and based on the response, the server's either going to be vulnerable or not vulnerable. So we can see it's being made with curl, where the target URI, that's the variable there, / password change CGI. So it looks like one of the prerequisites for this, for this exploit to work, or for this vulnerability, is the fact that Webmin needs to be configured to allow, or needs to have the password change functionality enabled, is what I'm guessing here. And we can see the parameter being injected is old. That's why we have the ID command here, which is a system command. And then, of course, we have the cookie and all of that good stuff here. And then you can see that if the result equals 0, vulnerable, or well, actually not the result. What is this referring to right over here? Let's see. So URI1 flag, yeah. So if where is that actually being referenced? That's very interesting. But yeah, the bottom line is the result is, if the result, I'm assuming, equals 0, vulnerable, not vulnerable. Okay, quite interesting. We can actually probably take this script and sort of see what it's doing, or what the response looks like. In fact, before we actually run it, I'm going to fire up Wireshark here. And can I search for Wireshark? There we are. We actually have it. Good stuff. So we'll get that running, and we'll start a captcha on Ethernet 0. Quite a bit of traffic. So chmod, we'll say 47293, and then I think we need to specify some parameters, obviously. Wait a minute. It's checking. Do we need to modify that? That's weird. This target is not vulnerable. I didn't specify a target. So where do we need to specify the URL? So it's first parameter. So that means nothing else, just specify the target there. So this right over here, just copy that. Very nice. Hit enter. Wait a minute. What on earth am I doing here? Oh boy. Yeah, say 4. And we'll just hit enter there. There we go. Wait a minute. Target is not vulnerable. Huh. Oh, there we are, vulnerable. We can probably improve the script here to sort of cater for escape characters, but there we go. It is indeed vulnerable. Now, I wanted to see what the response was in Wireshark, so I'm just going to stop the capture here. And can I actually zoom in? I can. All right, excellent. Let me just zoom out. I went a bit crazy there. IP.destination is going to be equal to 192.168.125.100. So IP, yeah, we sent some stuff there. Let's see what was actually there we are, post. We have it there. Let me just drag this here. So that was the request there. We can actually see this here. And then we change this to us, the IP of the Kali Linux system. And we say IP.source is equal to the web server to see what it sent back. 125.100. Let's see that there. We should see a response here. Let's see, line-based text. Wait a minute, I think that's, did we do that right now? Also change hypertext transfer protocol. There we are. Let's see. Okay. Status code. Yeah, so it's just checking for the response. Anyway, we can actually keep Wireshark running because we might need it in a few seconds. So the bottom line is we can pretty much just fire up Metasploit and then exploit Webmin and keep it moving. All right, there we go. All right, so I'm just going to search for Webmin here. And the exploit in question is number 10. So we can actually say use 10 right over here. And we are going to... we can keep the payload. I don't think we need to change that at the moment. And say show options, set global R hosts to 192.168.25.100, the IP address of the web server, and set global L host to the Kali Linux IP, which is static, so it'll be the same for you guys. Okay, and we just hit enter. Let's show the options here. So there we are. We have that. We can leave it the standard 4444. Target URI, nothing special. We know it's running on the root of the web server, so under no directory. So we don't, this is unauthenticated. And obviously we can show the info here. So this module exploits a backdoor. Actually, this is the backdoor one. But this should work as well, I think. Actually, let's try this module. Yeah, this was the backdoor exploit, but this should work nonetheless because it's still the same version, affects the same version. We don't need to provide anything else. Do we have to set the target? Do we have any other targets? Set target. Unix, Linux, it's automatic at the moment. So let's trust the module. So we'll just hit exploit. Yeah, looks like it's working. Does it send the stage successfully? Hopefully. Let's see. There we are. We get a command shell session. We can confirm that we have root. Indeed, we do. Okay, so let's put this in the background and let's upgrade that really quickly to interpreter session. So we have some stable or a semblance of stable access on the target. So there we go. Well, we should get an interpreter session, no problem. Indeed, we do. Okay, so sessions. Sessions 2 and sysinfo. All right, so Ubuntu 18.04, good stuff. Verify that. There we go. Very nice. We're currently in the Webmin directory. Okay, confirm that. So user local Webmin. No. Okay, excellent, excellent. So now what we are going to need to do is, there's a couple of requirements or environmental requirements for the rootkit to work. We obviously need an Apache web server, but more importantly, we actually need the Apache2 dev package installed, which is the development kit, which I think I mentioned in the wiki right over here. So this is this deals with getting initial access. If we go to post compromise, I believe I mentioned what this package does. So yeah, there we are. This package provides development headers and the APXS2 binary for the Apache2 web server. And the reason why we require it is because this particular rootkit, the Apache rootkit, pretty much is an Apache module, and you'll actually see how it works. I think I mentioned it over here. Let's see. Yeah, so there we are. So we can leverage the ability to load Apache2 modules to load our own rootkit module that'll provide us with the ability to perform command injection attacks on the web server and consequently spawn a reverse shell whenever we require. And the reason for this, in terms of persistence, is we never want to rely on an exploit to, as a form of access, because this vulnerability, the Webmin vulnerability, may be patched. So we want something that is clandestine, that sort of works with what is already on the server. In this case, the Apache server, the Apache web server that's hosting the public-facing website, and we want it to be, just blend in with stuff. So this is the link to the rootkit. Now, I think this rootkit was removed from GitHub recently, but the good thing is it is available within this lab. So I don't know, I'll try and see if there's a mirror that's hosting it if you want to, try it out for yourself. But, I've used it for a very long time. But yeah, so, in order for us to compile this, we're actually going to require the APXS utility, which I also mentioned over here. But the bottom line is there's a couple of important things I want to mention. So on the Kali Linux system, there's the Apache Rootkit directory that's stored on the desktop that essentially contains the source files. Now, we cannot perform the compilation on the Kali Linux system. We need to do it on the target system. So why don't we check and see whether we have the Apache2. I'll just open up a shell session here, bin bash I, and we can then use dpkg and list out the packages and then just grep and match exactly for Apache2 dev and see whether we have that. If we do, then we're game. And indeed, we do have it. Obviously, I would know about that. But what we now need to do is I'm just going to go back into Meterpreter right over here. And I'll open up a new tab on the Kali system right over here. And you can see that on the desktop, we have the Apache Rootkit folder. So there we go. And we have the makefile mod.auth mod.authg.c. This is the actual module. This is the source code for the module. And in here, the way it works is as a module, it essentially sets up a specific handler or a handler with a specific name. And this specific handler works, with Apache. So that means when you access the handler, in this case, the handler name is just authg. You can actually change this before you compile it. But this handler allows us to utilize the, let's see if we actually have it in here. Yeah, so if we take a look at the logic, you can see right over here, AP args to table are get. So authg, if, string compare r handler authg return declined. So what happens here is AP args to table are get. So get request over here, the set content type text HTML. Right over here, the bottom line is if we make a request to this and include a parameter, and then we just need to include a parameter and then the value being the system command we want to execute, it'll be executed under the context of the web server or the privileges or the user that the web server is running with. So most likely it's going to be www data, which means as a form of persistence we would lose our lose the root privileges, but that's not really the objective for this particular video demonstration. Anyway, what we need to do is we need to actually transfer this onto the target. So my bad, let me just take a step back here, and we're going to say tar we need to create one. So well, let's say CVZF and Apache, we're just going to call it rootkit .tar.gzip, and then we want to compress Apache rootkit like so. There we go. Okay, now we can leverage Meterpreter's inbuilt upload functionality. We're going to upload this in the temp folder. Okay, so we're just going to say upload. It's stored on the desktop. So, Apache rootkit. Sorry, not Apache rootkit. I'm losing my mind here. It's rootkit, we called it. There we go. Excellent. So we can actually open up a shell. And then, of course, we need some form of functional shell. So we'll just get a bash session. There we go. And then tar xzvf rootkit, just forgot no job control there, .tar, tar.gzip. and just extract that there. And in here now, Apache Rootkit. Let's see what we have in here. Yeah, so mod-auth-g, and now we can utilize the apxs command or utility, which is again part of the Apache2 dev toolkit. So we can just say apxs compile I mod-auth-g.c. So we can do that right now. So apxs and mod auth-g.c, and we can hit enter. And what this is going to do, by the way, this needs you do require root privileges, but the bottom line is what this will do is it'll compile the module or the shared object, I should say, and it's going to save it in the default Apache2 modules directory. So you can see actually right over here, libraries have been installed, shared library has been installed in the following directory. And now we actually need to add a configuration to the default Apache 2 configuration. So given that we don't have any job control in this bash session, we can actually utilize Meterpreter's, I believe it's the edit command, and we say, edit etc Apache2, let's see, Apache2.conf. Yeah, that should work. Very nice. And we need to copy in a specific configuration. We can just add it to the top of the file. This configuration is specified right over here. So we're essentially telling Apache within the default configuration to load this specific module, because it's copied to the modules directory, but we actually need to tell Apache to load it and to actually use it. And then the location, this is sort of the handler or the endpoint through which we'll access it. And this needs to match what the name of the handler, I think, I'm actually pretty sure it does, the name of the handler that was specified in the actual source code before you compile it. So if you use something else, make sure you change it here. Now, the handler, obviously, in terms of defense, evasion, and persistence or continued persistence, needs to be something that blends in with the traffic. Because if someone's monitoring the traffic and they're seeing a huge number of requests being made to auth-g, and auth-g is so out of this world crazy and out of the ordinary, they'll probably investigate it. So you want to go for something like contact or index or something like this, something that blends into the standard or normal traffic, other resources or pages that individuals are accessing. So we just need to copy this in here, and I'll just paste this in here. Unfortunately, it doesn't look like I can. Can I actually? No, probably not. Let me undo that. Do I need to paste it, or let's see. I'll just go open up this here. No, it's not. That's very weird. Let me just copy it. Just give me a second. All right, there we go. Copy that in there. Let me just make sure it's good. Yeah, there we are. And we write in quit, and then we can say system. Actually, hold on. We probably need a shell there. So bin bash I, and there we are. So we can now say systemctl restart Apache, because we obviously need to do that. And then we can check the status. Status Apache 2, right? And we can see loaded active, no issues. Okay. So now the way to access the rootkit is again via the handler name. So auth-g, like so. And then we can say command is equal to ID. No, what am I doing? This is the web server, not the webmin. So we can say auth-g, like so. We can see it's working. So I believe it's C is the actual parameter name. And then we say ID. There we are. And we can see we now have a command injection. And the cool thing is again, this is not a web shell, or there's not, any PHP file that's processing this. It's actually baked into Apache at this point. So, I think we should be able to, with Wireshark, if we start a new capture, actually, hold on, before I do that, I'll just change the destination IP here to the IP of the web server, so we can actually see what we're sending. Now, the web server is not running with an SSL cert, which means, it'll be intercepted, but I just want to show you what the traffic would look like, and you'll actually see the get requests being made. And this is why you should probably change it. But if we go in here and I list out, for example, who am I, for example, like so. Let's see what we have in Wireshark. So we can actually see that in here. Wait a minute. That's the destination. Yeah. Let's see. Where is this being sent? Now we probably also want the response, which is actually, no, we can actually see that here. There we are. So that's pretty much, how it works. And as I said, you probably want to make this as clandestine as possible. Actually, is anything being displayed here? Let's go ahead and try this one more time. Just want to see what this looks like. Lit URL encode. Yeah, it did work. Okay, so it's working very, very well. There we go. We can see that there. And we can actually see that. Very nice. Okay. So that's pretty much the gist of it. Now, in the wiki, I also mentioned now how you can sort of, instead of making continuous requests, you probably want something approximate to a shell or a pseudo shell, and that's where a tool like Comics comes into play that automates command injection. So the way this will work is, if we say the IP of the target, and then we say auth g c is equal to ID, for example. There way it's going to test. There way it's going to say the parameter c is indeed vulnerable. Do you want to prompt for a pseudo terminal shell? Yes, I do. Thank you very much. And now we have a pseudo terminal shell that is not perfect, but it gives us what we want. And there we are. You can actually see if I say who am I, it'll still be www data. So we lose the root privileges, but this is the best way of establishing very stealthy form of persistence. I know this video is pretty much titled Defense Evasion, and it is because, again, this is leveraging, from the perspective of red team operations, this is living off the land. You're using what the system already has. You're not downloading anything new apart from the rootkit, of course. You're not transferring anything you're not making too many changes. You're not installing much. Obviously, if the web server does not have the Apache2 development kit, then you'd need to install it. The reason it was pre-installed in the lab environment is because the lab environment is not connected to the internet. Anyway, in the original guide on my blog, HackerSploit.org, at the end here, which this one is much shorter, not really as detailed, but I also listed out a way you can actually upload a PHP backdoor, which I don't recommend really, because again, you're transferring stuff in that is quite easy to detect. But for example, you can generate a PHP shell with not a web shell, sorry, just another PHP backdoor. You can generate a PHP shell, and then in this case the listener would be through Metasploit. You can actually upload a shell with Comics. So you can utilize the file write command, or the file write command right over here. And in essence, if I just copy this here, you can actually see how this will work. So I'll open up a new tab here. 1 second. Let me just we can actually I'll just open up a new terminal here. By the way, do we have any web shells? User share web shells. Let's see which PHP ones, because this is an Apache web server. Sorry, my bad. There we are. Reverse shell backdoor, PHP backdoor. I think we'll upload this. So I'll just There we are. Just copy this to the desktop here, the Kali Linux system. And we'll just rename this to just bd.php. Very nice. Okay, so we can now say comics user, there we are, and sorry, not user, URL. We can say file right, and that will be equal to, we need to specify the absolute path, so home range range admin desktop, and we just bd.php, I believe it's called, and then we would need to specify the file destination, so where we want it saved on the web server, which would just be the web root for Apache, var www.html, and we'll save it as backdoor.php. Yeah, I think that pretty much should work. Yeah, let's go ahead and hit enter. Trying to write. Did that work? Who knows? Only way to find out is to find out. So we saved it on the root of the web server. So bd.php. Did not work. Very interesting. Did I make a mistake with my file right home range admin desktop? That's where we are. bd.php file destination var www.html bd.php. Is that actually the if I just check the Linux server, because I did add SSH access, so you can actually access the target web server if required. So I say var www.html. Yes, indeed, that is the web root. Not sure why that did not upload, but that should have uploaded. Let's see. What have we? I'm not really sure whether that is file destination. Yeah, that looks like the correct command there. File right. Let's change this to maybe shell. I'm not really sure what's causing the issue here. No. No. Interesting. Oh, that's very strange. It should have actually saved it. No, it doesn't. Interesting. This is very interesting, I have to say. Unless I'm making a mistake here. Let's see. Yeah, file right. Yeah, file destination. That's what I did. And I'm assuming there's no difference. Yeah, var www.html. And we do have permission. Data is the owner there. This is very interesting. What if we just say... Yeah, it doesn't seem to work. Anyway, that was part of the older guide, but you can sort of extend access if required. Yeah, so definitely give this lab a tryout. As I said, I'll put a link to this specific lab on the CyberRangers platform in the description section. Let me know what you think. There'll be others following. Of course, there's you can try out the CVE labs, the dirty pipe being one of the primary ones. And then we'll also be leveraging this one right over here, this playlist of labs for the adversary emulation series, again coming this month. But yeah, registration is free. If I just log out here, just need to very easily register. The link is app.cyberrangers.com. Anyway, thank you guys very much for watching, and apologies for the long sabbatical from my end. But now I think we're, pretty much geared and good to go content-wise. And with that being said, thank you very much for watching. Let me know what you guys think in the comments. I'd love to hear your feedback. And with that being said, that's going to be it from my end. Everyone take care, and I'll see you in the next video.